So in this class, I'm going to talk about the electric potential energy. So electric potential and the potential energy from a point charges. So this is the main equation that we're going to use. And the potential at the point. So for example, this sum should go from I equals to 1 maybe to I equals to n. Whenever you have n sources. Now let's look at this example here. Suppose that I just have one source, Q1. Then I can calculate what the potential at this point is by using this equation. So V1 is just going to be equal to P. So R12 is just the distance from this point to this point right here. So it means that if I were to place a test charge at that point, then I can calculate the energy. Remember we said that energy is just going to be equals to the, so you take Q2 and you multiply by delta V to get what that energy is. So this would be something that is in use. Now, I think the way to think about this, so let me share my other screen. All right, so let's look at this. So suppose I have Q1. So in Q1, if you remember that this is my source charge. You know that the electric field is coming out in all directions like this. Now let's suppose that I have a test charge Q2 that is right here. I will say that Q2 is at infinity. It's very, very far away. I want to calculate the amount of energy that it's going to take to remove this charge here and place it at some point P, such that the distance between this point and this point, you can call it R12. Now, if I want to calculate this energy, so what is the amount of energy here? Now, remember that because this charge is positive charge, so when I'm bringing it here, I'm moving in the opposite direction of the field. So I need work, I need to push. And we can calculate, so we can calculate that energy by taking, so the very first thing is to calculate we know that the potential at any point, KE Q1. So what is the potential difference between point P and point at infinity? Is going to be KE Q1 over R12 minus KE Q1 over infinity. So this is just going to be equal to KE. So once you know that, then you can calculate this energy by taking test charge times delta V, which should be equal to Q2 VE into Q1. So in this case, we assume that the source is at infinity. And then you want to move this source from this point to this point. So you need to calculate the potential difference between point P and point infinity. Now at infinity here, when you put R equals to infinity, this will just give me 0. And so you end up with just this first term. So if you multiply this by your Q2, you end up with this final result right there. Okay. So I'll go back to my, let's go back to the PowerPoint. Now, so this example, what it does here is that we're trying to calculate the potential energy for a system of 3 charges. And the way this works is that you're going to start with Q1 and ask yourself, how much energy does it take to bring a charge from infinity so if I were to move Q2 from infinity to this point, then the energy would be this contribution right here. So the first term in that expression is the amount of energy that I need to move a charge Q2 from infinity to that point such that the distance between Q1 and Q2 is equal to R12. So now you have 2 charges. Then let's bring a third charge to this point. Now, if this is my Q3, notice that to bring Q3 to this point, I need to work against this electric field here, as well as this electric field here. So I need to calculate how much amount of energy is it going to take me to bring Q3 from infinity to this point, right? Is this term. So Q1, Q3 is this term, and then Q3, Q2 is that term as well. So if you just add contributions from each, so the very first thing is that you start with Q1 as your source. And then you calculate the amount of energy that it's going to take to bring Q2 from infinity to this point, which is this term. Then once you have that, you're going to, so when you do calculations for Q3, you're going to say that Q1 and Q2 becomes your new sources. And so when you calculate that, you get these 2 additional contributions that you see right there. So this is very important, for example, in chemistry, when atoms come together to form molecules, right? So you can see it. So this is very important in the formation of molecules from atoms. Right? So that was just one example. So now let's do one, and I think this example is going to be useful for the drill tomorrow. So let's look at this example here. So this is example number 24.3. And so suppose that we have 2 charges, Q1. So Q1 is the positive charge, and Q2 is the negative charge. Now it says that Q1 is located at the point 0, 0. So this is my Q1 here. So this is Q2, and this is Q1. So for part A, I want to calculate the potential difference first I want to calculate the total electric potential due to these charges at point P, whose coordinates are 4.00 and 0. So notice that point P is sitting right here. So all what I need to do is that I need to calculate this distance here, R1, and this distance here, R2. And then I calculate my potential using this equation. Again, remember that to calculate potential, you don't need any X and Y components, right? Electric field is a vector quantity, so you need X and Y. Potential is very easy to calculate because you just plug in the numbers. You don't need to take X and Y components. So if you go ahead and plug in those numbers, you see that my R1 is equal to 4.0. Now, how do we calculate this R2 here? So how do I calculate the distance R2?
Pythagorean theorem.
Use Pythagorean theorem. So it's just 3 squared plus 4 squared, right? So 3 squared plus 4 squared gives me 25. You take the square root of that, you get 5. So it means that at this point P, the potential at that point is equal to this quantity. It's negative 6.2 times 10 to the power 3, and that is volt. Now let's look at part B. So part B says that find the change in potential energy. So now I want to calculate potential energy of the system once you introduce this test charge. So in this case here, it's just going to be your Q3 times the potential at that point. So you end up with this value here. So again, remember that the negative sign simply means that there's a decrease.